We're going to try something complicated today. I'm going to show how to build a synthetic stream of events representing a car driving around a real piece of road. I've done this with ShadowTraffic before. I've shown the output of what happens when you have the right coordinates to show a car driving around Seattle. But what I haven't really shown is the end-to-end way to do it. I've kind of hinted at services that I use and ways to pull this off. I wanted to show an end-to-end from scratch demo today of a car driving around the streets of Philadelphia. And so I'm just going to jump into it. So what I'm doing is I'm going to start with Google Maps, and I'm just going to grab random pieces of road. What I want to do is have a car driving around some of these roads. You can pick whatever you want. What we're going to do is pick up particular latitude, longitude values on a real piece of road, feed it into a service called OpenRouteService, and it will give us the segments that the car should actually drive along. And then we will then feed that into ShadowTraffic, into Postgres, into Grafana, and onto a map that will look really nice. And so you'll see the whole thing here. So I'm going to keep this really simple. I'm just going to grab a random piece of road here, somewhere on Pine Street in downtown Philadelphia, and I'm going to record the latitude and longitude values. So we'll start here, maybe we'll zip down here, and then yeah, I don't know. Let's go up here, and yeah, finish it off. Here's good. Okay, so what I'm going to do is take all of these lat long values, and then I'm going to feed them into something called OpenRouteService. This is a great service. It has a bunch of APIs for working with geodata. I'll have rotated this API key by the time the video goes out. But yeah, it's a free service. You can pay for it to do additional stuff. For the stuff we're going to do, it's free. We're going to go to the API playground, and the directions API has a whole bunch of different things. What we're looking for is the geo-JSON API. So if you click this, it gives you an example of how to use it. This will basically return kind of the road coordinates, and you can give it all kinds of parameters. You can even show us some example code. And what we're going to do is we're going to invoke this with our latitude and longitude values. So one thing to note is that OpenRouteService actually works in reverse in terms of latitude and longitude. So it operates longitude, latitude. So giving data in and feeding data out, you have to reverse it. So what I'm going to do really quick is take these pairs and ask, please reverse these pairs of numbers, format them as JSON arrays. Good problem for an LLM to do, especially if you have to do a lot of it. So that looks good. We're going to need to do this on the way out, or on the way in rather. So I'll just copy that, go down here. That's our formatted data. And then I'm going to copy, I already have this ready to go. This is the API call. It's got our key. It's got the geo-JSON route. And I'm going to fold all of this up, copy it, and rip out these old coordinates that I had in. And that looks good. Copy that. And now I'm going to run it. And what this will give me is the actual lengths the car should drive. Basically, it infers where the car would go based on the intermediary points that you give it. And so I'll take this over here, and it gives you a whole bunch of information. What we need is something called the geometry. It's in the body towards the bottom. I'm going to grab it, pull it out, put it up here so it's just easier to see. And then it gives me all these useful coordinates. But they're reversed again. So let me unreverse them. So back to ChatGPT. Swap my screens a little bit. Also reverse these pairs of variables. All right, hopefully it does that correctly. That's starting to look good. It should be, yeah, 39, -75. So while that's going, I'm going to boot up ShadowTraffic. I have a file here called drive, which is empty, and then I've got my terminal over here. And so what I want to do is say docker run, set it into network host mode so I can access Postgres and link it up with Grafana, mount my file called drive, and then just run it in standard out. Give me 10 examples of events. And so that's going to say you don't have anything in your file yet. Very fair. What I need are generators, and I need connections. And so I'm going to send the data to Postgres just because that's easy for the purposes of connecting stuff into Grafana. And it's going to tell me I need some more stuff. I want to send stuff into Postgres. I can't remember what else is there. Actually, the error messages are usually good enough to figure it out from here. So I want to have table, which routes, and row is no data. That's looking good. It's missing a key called connection configs, and I can just keep following the errors telling me what I don't have. I don't have a host, localhost, port is 5432, and DB is going to be my DB. And then I remember I also have authentication on this. Password is Postgres. That won't matter yet because I'm just printing stuff to standard out. Looks good. Okay, let's check ChatGPT, see whether it has my data back. Looks good. Okay, so I'm going to copy all of this, and then I'm going to bring in, put that in my scratch buffer. I don't need any of this other stuff now. All I need is this coordinates thing. I don't need this last thing called line string. But what I do need is a reference for a certain function called waypoints. So if I go to ShadowTraffic docs, I'm going to grab waypoints. This is our function that we're going to use. It basically models an object moving over a set of geospatial segments. I'm just going to go ahead and copy this example. So what we want to do is we want to create a variable that invokes waypoints. And I'll just go ahead and take this entire thing, come back over to my, my buffer with ShadowTraffic. Now I've got a variable. I'm calling a function called waypoints. And then the waypoints is what we have just received here. So I'm going to use this example data just for a second to make sure we have our orientation. So if I just if I just spit all this out, for instance, if I say, give me the variable of location, what we're going to see is a whole bunch of stuff. We're going to see latitude and longitude, which moves over time, the heading of the object, which will change, the distance it has to travel, which is static, the time it'll take, which is also static, how many points are in the distance, and then the duration between points. And so all very useful stuff. I'm actually just going to loop this. You can ask the object to just move in a loop. And I'm going to access just a couple of things. I'm going to say I want to have 2 columns. Latitude is grab the location object, and I'm going to grab just latitude. And then longitude, I'll do the same. Longitude. Okay, awesome. If I run that now, I just see my lat long values. This is looking good. So what I want to do is sub out my waypoints. This is just data from the example. It takes an array of maps, and each of those maps has to have a coordinate key. And so what I'm going to do is grab all of this. We're going to do some Emacs magic. Hopefully it works okay. Doing it live. Do some pretty print. Oop, that didn't help. Okay. I'll do I think what I need. Yeah, I need a map with a key called coordinates. So I'm going to do an Emacs macro coordinates. Put that at the back. Beautiful. Cooking with gas. All right, that was good. Fold that into an array. Unbalanced. Why unbalanced? There we go. Much better. Okay. Swap that out for my coordinates. Format it. If I run it, JSON error. Where's the JSON error? Tell me, editor. Right here. We're missing there we go. Okay, great. Now if I run it, I'm watching my object change. It's set to move at 500 kilometers an hour, which is very, very fast. I'm going to turn down the scale so it reports more often, and I'll let the object keep moving fast because that's just going to be more entertaining. So I have almost everything I need. If it's all going to go well, we're about to find out now. I'm going to actually do 2 things. I'm going to set the table policy to drop and create. So ShadowTraffic will automatically infer the right DDL for me for Postgres. And if I want to change it, and I probably will in a few minutes, it will just let me do that. It'll keep overriding it. So I'm going to take off watch, take off standard out, and I'm going to try to put 10 samples into Postgres and see what happens. And it blows up. What do I see? I see that latitude is of type JSON, but its type is actually a double. So ShadowTraffic is trying to figure out the right DDL. It can't really figure it out because this function is complex, and so it just guesses and says, hey, it's probably JSON. Instead, what I actually want to just do is say, override it with this function modifier, pghint. This will override the way that the DDL actually works when it creates it in Postgres and make it double precision instead. Everything worked, looking good. So I'm going to go check out what's in Postgres in my little Docker Compose. So psql -u Postgres, mydb. It's called routes. And that's looking really good. Now I've got some objects that are changing over time. I want to link this up now with Grafana. So what I'm going to do really quickly is I'm going to kick this off and just turn off sample. And what I should also do is to put a throttle on this. I don't want to generate data as fast as possible. What I want to do is to say, I want to have a local config where I'm throttling, and I'm doing that based off of some data in my my waypoints. So instead of longitude and latitude, there's as I pointed out earlier, there's a key called duration, which is the duration between points. And so this will move it at an appropriate speed. So if I run that, data should start indefinitely flowing through into Postgres. So I'm going to jump over to Grafana, and now I'm going to hook up data source. So if I do new connections, or not new connection, I want a new data source, add a data source for Postgres, and then I'm, I think it's, PG5432, mydb, Postgres, turn off SSL. All very specific things for my setup, but good to go. And now I'm going to make a dashboard. So let's see it all hopefully come together. So if I add it in, I'm going to use a geo map, and then I want to have there it is. I want to have the routes query. I want to grab everything. I'm going to grab more than 50 records. That's a little gotcha right there. You want to grab all the records. And then here we need to tell it where the latitude and longitudes come from. I just have to find it real quick. Run the query. If I do that, I'll see my data's there. That's looking pretty good. And it looks like it actually already figured it out. So if I jump all the way down here, ooh, it went really, really fast. Maybe 500 kilometers an hour was much too fast. I'll save this. That looks good. Pop this open. Give us data for the last 5 minutes. And then, yeah, that object's been moving. It went in kind of a funny pattern. I didn't really plan the road segments very well, but I'll refresh every 5 seconds. And to make this hopefully work a little bit better, I'm going to turn this down from 500 kilometers an hour. Too fast to be driving on the roads. And I save that, run ShadowTraffic again, bump over to Grafana, and now there we go. Now we see the object started to get plotted. And actually, I will turn it up again. That's probably a little bit too slow. Let's do let's do 200 kilometers an hour. Let's go nuts. Run ShadowTraffic, and beautiful. Now it's starting to move. Now what this is actually doing is this is plotting like a single car, and it's just showing a point per where it was at. You could use Kafka and Postgres to basically only emit the last reading, which would actually be a little bit more useful. You'd see a single dot moving around a map. But here we see the dots are actually moving around real segments of Philadelphia. It's presumably following the one-way streets, which there are many in downtown Philadelphia. And the service is super cool because it will make sure that the car stays on the road, it's going to the right place. And ShadowTraffic is able to use this data, appropriately generate the right data at the right speed based on what you want. It can even loop it and get it into the right target for you. And it's really, really fun to watch. You can fork this generator to run many cars. Instead of just one car, you can run 50 cars. You could stagger them out. You could do whatever you like. But yeah, this is how it works. And then hopefully it helps anybody building a demo, whether it's ShadowTraffic or not. I thought it was really cool to stitch this stuff together. And yeah, thanks for watching.